Students, now welcome to the second topic of ray optics, that is what is spherical mirrors. Now today we'll deal some introductory topics, introductory concepts of this spherical mirrors. How are the spherical mirrors formed? Simple job. If you take a hollow glass sphere, it is a hollow glass sphere, and if you take a section of it, okay, if I cut it here, if you take a section of it, this section of 10 will be actually circular in nature. This is a circular section. And when you think of the surface, from outside this part is convex and from inside this part is concave. Okay, so you will get a circular section, a round section whose this part is convex and this part is what? Concave. You will get a circular section actually, circular section when you cut the glass sphere. Okay, now if I polish it or silver it from the convex part, then this part is the opaque part, and from this side it is reflecting. This interior part becomes reflecting. The concave part of this becomes what? Reflecting, and the convex part is opaque. Okay, so when this convex part is opaque and concave part is reflecting, as the concave part is reflecting, this becomes what? Concave mirror. Okay, it becomes what? Concave mirror. On the other hand, when you take another hollow sphere, okay, and again you take a section of it, when you cut it from anywhere, then again you will get a circular part, circular section, this way, a circular section, whose this part is convex and that part is what? Concave. Circular section, this part is what? Convex, and that part is what? Concave. Are you getting it? Now this time if I polish it from the concave part, then the convex part becomes what? This part becomes reflecting. Here it was the interior part reflecting part. Therefore it was concave. Now here this part becomes what? Reflecting, which is actually convex. So it becomes what? A convex mirror. Is that clear? In that way you can form what? Concave and convex mirror. So when you take a glass sphere, you have a section of it, and suppose from outside, if I polish it, the interior part becomes what? Reflecting. That time it is what? Concave. On the other hand, if you take a hollow glass sphere, okay, and again you take a section of it, and this time if you polish it from inside, from the concave side if you polish, then the convex part becomes reflecting, and when the convex part is reflecting, it is called what? Convex mirror. Simple job. Now after this we'll deal with some basic terminologies, and the first term is what? Center of curvature. Okay, so the first term we'll know is what? The center of curvature. Center of curvature. See, what is that center of curvature? Simple job. The center of the glass sphere of which the mirror is a part. That center is called what? Center of curvature. The center of the glass, hollow glass, from which you have taken out this mirror, that center is called what? Center of curvature. So your first point is very clear. Center of curvature is what? The center of curvature is the center of the hollow sphere from which we are obtaining what? The mirror. Now after that, next is what? The pole. What is that pole? Second term is what? The pole. Now be careful. I told you that this part, which is the reflecting part, okay, actually in two dimension it's seen like this, but in third dimension when you think, it is a circular section. Okay, when you think of this mirror, it is a circular section actually. Okay, and in this circular section there is a reflecting part which is compressed, and at the center of that reflecting part, okay, this point, the center of the reflecting part is called what? Pole. So what is that pole? Pole is the center of reflecting surface. So there is a circular section and its center, exactly the center of the reflecting part is called pole. The center of, this is the reflecting part, its center is called what? Pole. Are you getting it? So when you think, actually it is a circular section, reflecting surface, and its center is what? The pole. Now next is what? Principal axis. Next term is what? Principal . What is that principal axis? The line joining the center of the spherical surface, the mirror or spherical hollow sphere, and the pole. Line joining the pole and the center of curvature is called principal axis. Line joining the pole and the center of curvature is called principal axis. What is principal axis? This line, horizontal line. What is that? Principal axis. After that, next is what? Radius of curvature. Next is what? Radius of curvature. So, you all know these things as you have studied in your 9th standard. Radius of curvature R. What is the radius of curvature? It is a distance between pole and center. This distance, here to here. This distance is called what? Radius of curvature. So it is the radius of curvature, which is the distance between what? The pole and center of curvature. The pole and center of curvature. This distance is called what? The radius of curvature. I think you got the concept there. Okay. Now after that, next concept is what? Aperture. Aperture. It is a very basic term. Aperture. What is an aperture? I told you that when you think of this mirror, actually it is circular. Its section is circular. The diameter of this circular section, okay, this diameter of this circular section, the diameter, it is a circular section of that mirror. This diameter, okay, the circular section is there, its diameter is called what? Aperture. This is aperture. So next terminology is what? Aperture. What is that? Aperture? It is what? The diameter of circular section, the mirror. It is the longest segment of the mirror, you can say. Okay, that is called what? Aperture. After that, next term is what? The focus. A very important point. Focus. What is that focus? Focus. For focus, we should take another diagram. To define the focus, we'll take another diagram. Okay. What is the focus? Next term. It is a point on the principal axis. It is a point on the principal axis. What is that point? If I take, suppose I will take a concave mirror. And for concave mirror, here is the center, here is the pole. Now, suppose on that concave mirror, light rays are incident parallel. They are incident parallel. Parallel rays are incident parallel, and actually they are incident parallel to the principal axis. The principal axis, you better know. Line joining the pole and the center is principal axis, and parallel to the principal axis, these rays are incident. Okay. Now, after reflection, you will get a point where all of these rays will converge after reflection. So, it is a point where all the parallel rays, which are parallel, incident parallel to the principal axis, these all rays are converging at a single point, and that point is called principal focus. This I have defined for what? Concave mirror. On the other hand, when you have a convex mirror, the definition will be almost same. There will be a little change. It's what? Pole, and it is the center, because this side the circle, the spherical portion, the whole spherical glass will have center this side. So for convex mirror, you better know that center is towards right of the mirror. Okay, so here is the convex mirror. On this mirror, when the parallel rays are incident, which are parallel to one another, and also the rays are parallel to the principal axis. Okay, the rays are incident what? Parallel to the principal axis. Then after reflection, what happens? These rays, they diverge because the convex mirror has a tendency to diverge the rays. Okay, concave is converging it, therefore it is also called converging mirror. It's converging the rays, while this ray, this convex mirror, it diverges the rays. Okay, so it is also called what? Diverging mirror. So when these rays fall parallel to the principal axis, okay, then these rays appear to diverge from a point. These all rays appear to diverge from a point. And that point is called what? Principal focus. So after reflection, what is happening? These rays appear to diverge from that point. After reflection, ऐसा लग रहा है कि ये इस point से निकल के आ रही है. When you retrace this reflecting rays, these rays will appear to be emerging from this point, and that is called what? Principal focus. So what is principal focus? When the rays are incident parallel to the principal axis. When the rays are incident parallel to the principal axis, either the rays will converge after reflection to a single point on the principal axis, that is called principal focus, or the rays will appear to diverge from this point after reflection. After reflection, they will diverge in such a way that the rays will appear to be coming from this point. So this point is called what? Principal focus. You can see here for concave mirror, the principal focus is also lying as the center of curvature towards left, and for convex mirror, the focus, the principal focus, is also lying towards right as the center of curvature. Okay, you got the point there. So what is principal focus? The rays which are incident parallel after reflection, either the rays will converge at that point, or the rays will appear to diverge from that point. That is called what? Principal focus. Now after that, next terminology is what? Principal focus, the focal plane. Okay, after that, next is what? Focal plane. So next term, focal plane. So again, for that I have to choose, I have to take a diagram. Focal plane. What is that focal plane? Suppose here you have a concave mirror, and again this is the pole, the center of mirror, and it is the center of curvature, and between these two we have another point, focus. We just have defined. For concave, the focus is in between pole and center of curvature. Okay, left side. Now this time the rays are incident parallel to one another. Parallel beam is incident, but the rays are not parallel to principal axis. Okay, the rays are incident parallel, but they are not parallel to the principal axis. They are parallel to one another, but they are not parallel to principal axis. In that case, it is found that these rays are converging to a plane. The rays are found to converge to a point which is lying on a plane passing through the focus and principal axis, normal to principal axis. Okay, so when the rays are incident parallel to one another, but they are not parallel to principal axis, then after reflection, these rays, they converge at a point which is lying in a plane which is what? Actually passing through the focus and perpendicular to principal axis. This plane is called what? Focal plane. So for, I can write in two dimensions like this. If this is the pole and center and focus, this plane, the plane which is passing through the focus and normal to the principal axis. It is the principal axis. तो प्रिंसिपल एक्सिस के नॉर्मल और फोकस से गुजरने वाली प्लेन क्या होगी? फोकल प्लेन होगी. एक चीज याद रखिए, अगर रेज आपस में पैरेलल है और लेकिन ये रेज आपस में पैरेलल तो है, लेकिन प्रिंसिपल एक्सिस के अगर पैरेलल नहीं है तो वो कन्वर्ज होकर हमेशा फोकल प्लेन में ही आएंगी. They will converge and they will what? Converge at a point which is lying on the focal plane. So these were few terminologies we were dealing with. Now after that we will go through some rules of image formation. Now we'll go through some rules of image formation. Okay, so some rules of image formation. Okay, so what are the rules? The first rule: if the rays are incident, okay, there is a ray which is incident. Here's your concave mirror and pole, center of curvature, focus. When a ray is incident parallel to the principal axis, then the ray will pass through the focus. The first rule. You got the point? When the ray is incident parallel to the principal axis, then it will pass through the focus, as we have studied in the definition of focus. Or for a convex mirror, here's a pole and here's a center and here's a focus. Now, when a ray is incident parallel to the principal axis on a convex mirror, then the ray appear to diverge from that point. So the first rule is what? What is the first rule? If a ray is incident parallel to the principal axis, then after reflection, the ray is either passing through the focus or the rays appear to diverge from the focus, reflecting from the focus. Are you getting it there? The first rule. Now after this, the second rule. Suppose it's converse. Suppose a ray is focus, center of curvature, pole. If a ray is incident, it is concave mirror. Okay? If a ray is incident through the focus, then after reflection, the ray becomes parallel, just converse. Okay? After reflection, the ray will become what? Parallel. Or if it is a convex mirror given to you, okay, here's the pole and center of curvature, focus, and suppose a ray is incident along the direction of what? Focus. The ray is incident along the direction of focus. Then after reflection, the ray would become what? Parallel. So when the rays are incident parallel, they pass to the focus. When they pass, they are incident along through the focus. After reflection becomes parallel. Here, when the rays are incident parallel, appear to diverge from focus. Or when the rays are incident along the focus, they become what? Parallel after the reflection. These are the two rules. Now, third rule. After that, we have the third rule. Now, the third rule says you what? If it is a concave mirror, pole, center of curvature and focus. In this case, if a ray is incident on the mirror through the center of curvature, okay, it is incident what? Through the center of curvature. When the ray is incident through the center of curvature, then be careful. Actually, it is incident normally because radius center, it is a spherical surface, it is a radius, and radius is always normal to the surface. You better know. For a sphere, radius is always normal. So actually, it is incident radially, I should say. When a ray is incident through the center of curvature, means ray is incident what? Radially. So when the ray is incident radially, means it is normal to the surface. Normal to the surface means angle of incidence will be 0. So angle of reflection should be also what? 0. So the ray will retrace back. So a ray which is incident through the center of curvature retraces back its path. Okay? Because to pass through the center of curvature, to incident through the center of curvature means you are incident. The ray is what? Normal to the surface. Normal means angle of incidence 0, so angle of reflection will be also 0. On the same way, if I draw here a convex mirror, the case will be the same. Now, if a ray is incident towards the center of curvature, you can see towards the center of curvature, then here also the ray will retrace its path. It will return back along the same path. You got the point? Is that clear? Now after that, the next rule. Fourth rule. What is that? If you have a concave mirror, here's the pole and center of curvature, principal axis, focus. Suppose a ray is incident exactly at the pole, making an angle I. What I told you earlier, just now in the third case, that this line through the center is normal. Okay, because radius is normal to the surface. It is normal. So you can say that this incident ray is making an angle I with the normal. So after reflection, it should be reflected in such a way that angle of reflection should be also I. So at whatever angle it is incident from the principal axis at the pole, at the same angle it is reflecting back. And for what? Convex mirror, pole, center of curvature. Suppose a ray is incident like this, making an angle I, then it will be reflected back with the same angle I. So whenever a ray is incident at the pole at an angle I from the principal axis, it is reflected at the same angle. You got the point? So these are the rules for what? Image formation. Okay? After that, we'll deal with some sign conventions. Okay? After this, we'll deal with some what? Sign convention. And sign convention is very easy. The first rule says that all the distances are measured from pole. Be careful. If you have either a concave mirror you have a concave mirror or a convex mirror, we measure all the distances from pole. Either you measure this side or that side. Pole is the origin, reference, from where we measure what? The distances. Either you measure towards left or towards right. Towards right or towards left. You will have to measure the distances. We assign the distances from what pole. Then second rule. Second rule says what? The distances which are measured along the direction of incident ray. Distances measured along the direction of incident ray. Okay, so generally we make the ray to incident from left to right, this way. So if I measure the distance from pole this way, it will be positive, and this way it will be what? Negative. So if you measure the distances along the direction of incident ray is what? Positive, and vice versa. Okay, along from the pole, along the ray, positive, opposite the ray, negative. Here also, from the pole, along the ray, positive. Opposite to the ray, negative. So you can check it, very simple thing. What? Now in case of concave mirror, when you think of radius of curvature, when you measure the radius of curvature, which is the distance between center from pole, you measure it from pole to center of curvature this way, which is opposite to the incident ray, opposite. So this should be negative. So for concave mirrors, this radius of curvature is negative. In the same way, this is called the focal length. Okay, when you measure it from pole to the focus, focal length this way. Here also you are measuring it from the pole opposite to the ray, opposite to incident ray. So we'll take focal length negative. So this is also negative for what? Concave mirror. On the other hand, when you measure the radius of curvature of a convex mirror, then you measure it from pole to center this way along the incident ray. So it is positive. In the same way, when you measure the focus, you measure focus also from pole to focus this way. So which is the direction of incident ray? So it will be also positive. So be careful. For concave mirror, focal length we are measuring opposite. Radius of curvature we are measuring opposite to the incident ray. So this focal length and radius of curvature, these two are taken negative. But in case of what? Convex mirror, when you measure the focal length from pole to focus along the ray, positive. From pole to center, when you measure the radius of curvature along the ray you measure, so positive. So very important thing we concluded, for concave mirror the focal length and radius of curvature negative, and for convex mirror the focal length and radius of curvature are taken what? Positive. Now this is the second rule. Now after that the third rule says what? The distance is measured, or height I should say, measured above the principal axis. Are positive. If I measure the distance above from the principal axis, above, if you measure the height from here to here, above when you measure the height, it is positive. On the other hand, if you measure it below the principal axis, from principal axis when you measure them below the height, it is what? Negative. So these are the rules of what? Image formation. After that, we'll go through some important image formations. Okay, we'll work out with what? Some image formations, and first we'll work out it for what? Concave mirror. So images formed by concave mirrors. Okay, first case. Suppose the object is at infinity. So when you have a concave mirror and your object is kept at infinity, from infinity parallel rays are incident. Okay, from infinity the parallel rays are approaching towards the mirror. When these are incident and after reflection, you better know that the parallel rays, they converge at a single point, which is called what? Focus. So image will be formed at what? Focus. So you can see, as real rays are meeting, as what? Real rays are meeting, so image form will be what? Real. So a real image is formed because real rays are meeting. Secondly, this is a point size image, diminished. You got the point? So from the focus, the rays are converging to the focus. From the infinity, the rays are coming parallel and they are converging to the focus, and image is formed at focus. So image is formed at what? Focus. And what is the image? Nature of image? It is real because real rays are meeting. It is diminished, point size. You got the point? Now second one, if I just keep this object beyond the center of curvature, you have this concave mirror pole, and here's the focus, and here's the center of curvature. Now this time I am keeping this object beyond C. When you keep the object beyond C, this is the object AB. What will happen? How can you form the images? Rules are there. When you make a ray to incident parallel to the principal axis, it will pass through the focus. Okay? And when a ray is incident through the focus, after reflection, it will pass parallel. Now, these are the rays which are meeting after reflection here. These are the rays which are started from A, the head of that object, and these rays which is incident parallel passing through the focus, which is incident through the focus is becoming parallel after reflection. These rays are meeting at this point. So here a head will be formed. So image form will be here. It will lie here. Okay. So what is the nature of image? It is real, because real rays are meeting. Inverted. It is what? Real and inverted. And its size is what? Smaller than the object. Not magnified. It is smaller than what? Object. So when you have an object beyond the C, in between C and infinity, then when you keep it in front of a concave mirror, you are getting what? An image formed between center of curvature and focus. It is a real image, inverted one, and is smaller than the object. Okay? After that, third case. In the image formation, third case is what? We have the we have the object kept at what? Center of curvature. Now, from here, a ray incident parallel will pass through the focus, and a ray which is passed through the focus would become parallel after reflection. So these two rays are meeting here. So you have an image formed exactly at the center of curvature. Okay? So when the ray is incident parallel to the principal axis passing through the focus, ray incident through the focus would become parallel, and these two rays which are started from the head of this object are meeting over here. So here the image A dash B dash is formed with the head here. This is a real image because real rays are meeting, and this image is real, inverted, and it has the same size as that of object. Okay, now next case. Next case is what? Suppose we have another case where we keep the object between the focus and center of curvature. Okay. In this case, a ray incident parallel will pass through what? Focus. Okay. And a ray which is incident through the focus is an object AB. A is the head of object. A ray which is starting through the focus would become parallel after reflection, and these two rays are meeting over here. So here the head will be formed, A dash, image will be formed here. Again the real rays are meeting, so real image is formed. The image form is what? Inverted. Okay, you can see it is bigger than the object, so it is magnified. So when you have kept the object at the center of curvature, the size what? The same. But when you bring the object closer towards a mirror, within the center of curvature, the magnification starts. So when you move this object, when it was beyond C, the size was smaller than object. When at the C, when you have kept the object, same size. And beyond and within C, when you put the object, it is magnified. Magnification starts when you keep the object what? Within the center of curvature. Okay. Now after that, next, when you keep the object exactly at the focus, suppose we keep the object exactly at the focus. When you keep the object exactly at the focus, what happens? Pole, focus, center of curvature, here's the object, a ray which is incident parallel would pass through the focus. A ray which is incident along the center of curvature. This is the ray which is incident along the center of curvature will be reflected back. A ray which will be incident here at an angle I, it will be reflected at the same angle I. Okay, a ray which is incident parallel is passing through the focus. A ray which is incident along the center of curvature is retracing the path. A ray which is incident, all of these rays are incident from the head. Now, I generally used to make the rays starting from head. So a ray which is incident here at the pole at certain angle I will be reflecting at the same angle I. Now when you think of these all reflected rays, these all reflected rays are what? Parallel. They are what? Parallel. So they are not going to meet. They are going to meet at infinity. So at infinity, image will be formed. And as the rays are going beyond, an inverted image will be formed. Are you getting it? And it is what? Having a infinite magnification, infinite size of image will be formed. You got the point? So when the object is kept at focus, a real, inverted and magnified image is formed at infinity. Now after that, next one. When you keep the object within the focus, center of curvature, focus, within the focus. When you keep it within the focus, what will happen? Object kept within the focus. Now, what are the rules of image formation? A ray which is incident at an angle I will be reflected at the same angle I at pole, and a ray which is incident along the center of curvature will retrace its path. Okay, and these rays are the diverging rays. They are not going to meet. Here the parallel rays were going to meet at infinity, but these are the diverging rays. These are not going to meet. So when you keep the object within the focus, what is happening? In this case, a ray which is incident along the center of curvature is retracing its path. A ray which is incident at an angle I at pole is reflecting at the same angle I. Okay, now these two rays are diverging rays. They are not going to meet, but they are appear to come from a point beyond the mirror, behind the mirror. Behind the mirror, these two rays appear to come from this point. Are you getting it? These two rays appear to come from this point. So here is the image formed. As the real rays are not meeting there, but rays appear to diverge from that point. So this image is what? Virtual image. Because real rays are not meeting. The rays appear to diverge from that point. So here you have what is formed? Virtual image form. So image form. So when you keep the object within focus, between F and P, objects lying, then image is formed what? Behind the mirror. Okay. What is that image? It is virtual because real rays are not meeting. The rays appear to diverge from that point. So it is what? Virtual, and it is erect. See the high image. Okay. So these are the cases for what? Concave mirror and the image formation through these concave mirror. Now, when you think of a convex mirror, how can you form the image? How can you form the image for a convex mirror? And is also simple. How can you form it? Now, if I take a convex mirror this way, principal axis, the center of curvature, focus, pole. And suppose in front of the mirror there is an object AB. And from the head of the object, suppose a ray is incident parallel to the principal axis. It is incident what? Parallel to the principal axis. You better know that in case of convex mirror, when the ray is incident parallel, after reflection, the ray appear to diverge from the focus. After reflection, it will diverge in that way that it appear to diverge from the focus. We have studied it in the definition of focus. Secondly, a ray which is incident towards the center of curvature, are you getting it? It will retrace its path. Because a ray which is incident towards the center of curvature retraces its path. Now again, from this mirror, the rays are diverging. And when these rays are diverging, they are not going to meet. But these two rays which are diverging, okay, these two rays appear to come from this point. It is seen that the rays appear to diverge from this point. So here will be the image formed. Because when the rays are incident from A, after reflection, the rays appear to diverge from this point. So here the A dash will be formed. And here is the image A dash B dash. What is the speciality of image? Image is formed behind the mirror. It is erect, see the eye, and virtual. So a convex mirror always makes a virtual image for any object kept in front. It always makes virtual image, and that virtual image formed is actually, it is smaller than the object. And this image is virtual image because real rays are not meeting. The rays appear to diverge from this point. Okay, so it is a virtual image form and it is erect behind the mirror. Okay, it is behind the mirror. So these are the cases of what image formation. Will conclude our lecture here. Okay, and in the next class we'll go through some more theory part and some derivations and some important formula and concepts which we'll be using for numerical approach also. Okay, so we are concluding our working here. Okay, bye.